Okay guys, today we are going to be still working with quadratics and we are going to start factoring by grouping. So some of this will look familiar. You should see what we did on Friday when we were just factoring the GCF. You'll see a lot of that from Friday and the rest of last week. That'll come back into play today. And we're just adding a little extra layer to our factoring. So when we talk about factor by grouping, you need to be able to identify which type of quadratic you need to use factor by grouping on. So I've got your success criteria outlined here, and we're just going to highlight that if the expression has 4 terms, then we're going to use factor by grouping. Okay, so if you look at the example that I have here, we have 4 terms, and we are going to take these 4 terms and we are going to group the first 2 terms together with parentheses, and we are going to group the second 2 terms together with parentheses. Okay, and I do want to add that it's super important to make sure that you keep your sign with the term. So if you look here in my second grouping, I kept the plus sign with the 2. Okay, so now that we're here, we are going to look at each of these as separate problems. Okay, so I'm going to look just at the first grouping, and I'm going to look for what the GCF is. So if I look at x squared and 5x, if I look at these two, I'm looking for the greatest common factor. Well, 1 and 5 don't have anything in common, but both of these terms have an x. So I'm going to factor the x out of x squared plus 5x. Okay, this is just a GCF problem just like we did yesterday. So when I divide out the x, or when I factor out the x times what is going to give me x squared? Well, x times x gives me x squared. X times what is going to give me 5x? X times 5 would give me 5x. Okay, and you can imagine if you were to go back and distribute this in, you should end up right back up where you started. And if I distributed the x into this binomial, I would get x squared plus 5x. So you can always go back and check yourself. Okay, so now we're going to look at the second group. And the second group is 2x plus 10. So I am looking for the greatest common factor of 2x and 10. Well, they both don't have x, but 2 and 10 are both divisible by 2. So I'm going to factor out a positive 2. And when I factor out a positive 2, 2 times what will give me 2x? 2 times x will give me 2x. 2 times what will give me 10? 2 times 5 will give me 10. Okay, and hopefully you notice that these 2 binomials are the same. Okay, if your 2 binomials are not the same, you have not factored the greatest common factor. Or maybe you've made a mistake in factoring, but you cannot move any further unless both of those binomials are the same. And then this just becomes a problem just like we did on Friday. So we're going to factor out the common binomial, which is x plus 5. And then we're going to bring down what's left into the second binomial. Okay. And you're done. X plus 5 times x plus 2 will give you that quadratic that you have listed above. All right, let's take a look at another example. Okay, again, identifying that we have 4 terms, so we are going to use factor by grouping. Okay, I'm going to rewrite this, and I'm going to group my first 2 terms together with parentheses, and I'm going to group my second 2 terms together with parentheses. And you might even want to make a little note here that even though this is plus x, this is really plus 1x. So even though there's not a number there, there actually is a 1, even though you don't see it. Okay, let's take a look at our first group. Our first group is 2x squared minus 12x. So 2 and 12. 2 and 12 are both divisible by 2. That's the greatest common factor. And then they both have an x. So I'm going to bring out the x. Okay. 2x times what will give me x squared? Well, 2x times x will give me x squared. 2x times what will give me negative 12x? 2x times negative 6 will give me negative 12x. And again, you can check yourself by distributing in. If I distribute that 2x into the binomial that I have there, I will get 2x squared minus 12. Okay, let's look at the second binomial. I have 1x and negative 6. 1 and negative 6 have nothing that they're both divisible by, so I'm just going to put a plus sign out there. And you can see now that we have the two binomials equivalent to each other. Okay, both binomials are x minus 6 after we have factored out a GCF. Okay, so we're going to bring the common binomial out in front, and then we're going to bring down what's left and make our second binomial. So I have a 2x, and then I want to be careful because what is really hiding out here is a 1. So when I bring the 2x down, I need to bring the plus 1 also. Sometimes you'll have a number there besides 1. Sometimes you'll just have 1, but you need to make sure that you have two binomials, that there is actually a number 1 there. All right, guys, that's all I've got for today.